Hello everyone. I'm Sanjana Gunna, and today I'll be presenting my presentation for the course Computational Photography, and this is my final project. And the topic that I've chosen for my final project is editing motion blur in still images. So before jumping into the topic, I would like to briefly discuss the content of the presentation for today. I'll be briefly discussing the motivation of this problem and also the exact problem statement, and then we'll be jumping into the methodology and also the experiments that I've conducted, and also followed by the results, mostly qualitative in this case, and then finally we'll be discussing the future scope of the project. So yeah, so coming to the motivation of the project. Before jumping into the motivation of the project, I would like to briefly discuss what motion blur actually is. So, motion blur is usually captured in images due to the presence of relative motion between the camera acquisition setup and the scene that is being captured. So, it could be linear or non-linear in terms of like translation or rotation or even sudden change in the scale. So, it has widespread applications in commercial applications. And coming to the motivation, you could find applications in industries like film and animation, where uh, using motion blur could actually add a dynamic element to still images, therefore enhancing the visual effects. So one of the applications would be to help simulate certain animation effects that appear realistic, mostly in case of like action scenes or fast moving scenes. And the same could be applied to gaming, AR or VR, to create immersive backgrounds for gamers and viewers, and therefore enhance like viewer experience. So, but despite all of this artistic appeal of motion blur, there has always been research going on in computational photography in order to eliminate motion blur in captured scenes. So, but however, in our project, we are aiming to actually induce motion into still images and apply it to different objects in the scenes. It could be the foreground or the background or different or multiple objects in the scenes. As you can see here, the car could be animated to have motion blur, or it could be the background in the scene. So coming to the method, I've briefly cut down the whole process into 3 steps. So for the first step, I'll be discussing about motion blur kernels, or also called as point spread functions. So these are essential in inducing or eliminating motion during motion blur deblurring, and it essentially captures the motion in the scene, and these could be linear or non-linear as mentioned before. And in this case, I have used random step sizes and random rotations and random translations incrementally to create such PSF kernels, but these could be uh, taken as input from the users to exactly uh, induce certain motion. So coming to the next slide, it's the next step is using different, as I mentioned before, we need to use different objects. In order to capture different objects, we need segmentation mask. So we use a SAM model to actually extract the segmentation mask of different objects in the scene. And now that we have those masks, they have that information, what is left to do is convolution. What we have to do is convolute with the PSF in order to induce motion into the scene. And this is done separately object wise. So once you have if you want to induce motion into the foreground, you would directly convolute it with this PSF, and then convolute the mask with the PSF, and then invert it to capture the motion that is induced or indirectly induced into the background because of the foreground, and then combine both of them to get the final result. So it somewhat looks like something like this. But the problem is that there's a lot of artifacts near the boundaries that we need to get rid of, and it doesn't actually solve this. So the next step is that I've looked into is to directly implement Poisson blending. So Poisson blending is is a great method to actually do a seamless merging of two images that are that are of different that belong to like different domains. So it is a guided interpolation method where your source image is pasted onto the target image based on the gradients of the target image, and that's how both the source and target are combined based on that. And this is what we get after doing Poisson blending. And these are some of the results. You could select the person and the object and then try to animate the background, and this is something that we get after Poisson blending. You get a much better result. And similarly, for this example, you could animate the tree or the clouds in the scene and get different results. And since Poisson blending is not always perfect and it kind of doesn't actually transfer the illumination properly, we could look into more of or better blending methods, and that would be like the one of the future scopes for this project. And other than that, motion blurring could also be applied in a way where uh, it's not just uniform motion blur. You could have like a multiple directional motion blur for different specific parts in the scene, and that could even enhance the visual appearance of the images. So that's all for the presentation. Thank you.